Hello, my dear students, and welcome to Imavate. My name is Sunando Devnath. In this video, we are going to start with the 8th chapter of physics of class 9th, propagation of sound waves. So here in front of you is this chapter. The PDF of this chapter is opened up from Concise Physics of class 9th. And I would be explaining this chapter in detail. And also I would be asking you to underline the important things, the places where you can get a lot of questions, and each and every topic will be discussed in this chapter in a beautiful manner. All right. So you can see right at the beginning, they have written the syllabus that you need to do for this chapter. All right. So let us start the chapter. What is sound? Basically, the sound is a form of energy. So here goes the first important thing, which is the definition of sound. Sound is a form of energy that produces sensation of hearing in our ears. Okay, so this is the definition of sound. It can come in your exam. You must learn the definition. Sound is a form of energy. All right, and what does it do? It produces the sensation of hearing. सुनने का sensation कहाँ produce करता है? हमारे कानों में, in our ears. Next important thing is that sound is produced when a body vibrates. A very important fact. Okay, so how is sound produced? You would write the answer. Sound is produced when a body vibrates. Whenever there is a vibration in the body, sound can be produced. But if there is no vibration, sound cannot be produced. So sound is produced only when a body vibrates. Now, this fact can be demonstrated or can be proved by these 3 experiments which are given below. So these are very simple and basic experiments, and we all can do that. In fact, the first and the second one is so simple that even we can do it in our homes with the things that we have around us. It's very simple. All right. So what is the first experiment? Here, a person has taken a rubber string. All right. And one end of the rubber string is held between his teeth, and the other end he's holding in his hands. With the other hand, what does he do? With the finger of the other hand, he is plucking the rubber string and bringing it into vibrations. The moment he has plucked the rubber string, it comes into the state of vibrations. And now this man can hear a sound coming to his ears. Before, the string was, when the string was not set into vibrations, there was no sound coming to his ears. But only when this rubber string comes in the state of vibrations, he noticed that a sound is heard. So this proves that a vibrating body produces sound. All right, very simple. It is, see what is written. It is noticed, क्या उसने notice किया, that the string starts vibrating and simultaneously a sound is heard. और उसके बाद क्या हुआ? After some time, when the string stops vibrating, no sound is heard. Very simple. कुछ भी नहीं है, एकदम easy experiment है. The second experiment is also very similar to it. What is this? He has the person over here has taken a string, a metallic wire, a thin wire, and he has stretched it between 2 nails. These are 2 nails. Okay, तो 2 nails के बीच में tightly एक metallic wire को इस तरह से tightly stretch किया गया है. And then this is a wire without an insulation. Okay, means just the wire, the metallic wire, not with a plastic insulation on it. Because if you insulate it with plastic, then you won't be able to get the vibration very nicely. All right, so it needs to be very thin, and the metallic wire and a non-insulated wire. All right, so that you have taken, and so that you can see the vibrations even with the naked eyes, and vibrations are observed very clearly. What has been done, a paper rider is kept somewhere in the middle of the wire. Paper rider is basically a small bit of paper that is folded and suspended and kept on this wire. All right, now when the wire is not set into vibrations, the paper is at rest. Now what happens when you pluck this wire? The wire starts vibrating and this paper rider flies off. ये उड़ जाता है. Obviously vibration होगा तो paper rider flies off. So this flying off of the paper rider proves us that the wire is vibrating. All right, वैसे तो हमें naked eye से भी दिख रहा है कि vibrate कर रहा है, फिर भी हमने paper rider से भी ये दिखा दिया कि when the paper rider flies off, it means the wire is in the state of vibrations. And at that moment, a sound is heard. When the wire is vibrating, a sound is heard. But after some time, no sound is heard. When the wire would come to rest, no sound would be heard. And when again you place the paper rider on it, the paper rider does not fly off. It means that the wire is no longer vibrating and no sound is also heard. कुछ नहीं है, एकदम simple सा experiment है. So I'm just reading whatever I said is written. It is observed that the rider flies off as the wire starts vibrating and the sound is heard. After some time, when the wire stops vibrating, the paper rider placed on the wire does not fly off. So no sound is heard. Very simple, nothing it is. The third experiment to prove the same fact is this. What is being said? You see, a tuning fork has been taken. Also, what has been taken? A table tennis ball, okay, suspended from a rigid surface, and the table tennis ball is in the state of rest right now. It's not vibrating. The table tennis ball is in the state of rest. The tuning fork that you have taken, now what you have done, you hit the tuning fork on a rubber pad. Okay, when you hit the tuning fork on a rubber pad, the tuning fork comes in the state of vibrations. Now you bring that vibrating tuning fork near the table tennis ball. The moment you bring this vibrating tuning fork near the table tennis ball, it would hit the table tennis ball due to its vibrations, and the table tennis ball moves away. ऐसे move कर गया. So the moving of the table tennis ball shows or indicates that the tuning fork is vibrating, isn't it? Because if the tuning fork is not vibrating and you bring it near the table tennis ball won't move away. So only a vibrating tuning fork when brought near the table tennis ball would cause the ball to move away, है ना? तो ये जो ball move कर गया, this indicates that the tuning fork is vibrating. And at that very moment, when the tuning fork is vibrating, you would also hear a humming sound, a sound coming out. All right, so this, and when the tuning fork stops vibrating, no sound is heard. And the ball also, when you bring the tuning fork, which is not vibrating near the ball does not move away. This also shows that the tuning fork is no longer vibrating and hence no sound is heard. Very simple. What is the fourth and the fifth experiment? You see, it is simple. A small paragraph is written for experiment 4. Take a drum and beat it. Okay, school में तुम्हारा drum होता है ना, सारे schools में होता होगा. And you beat it. The membrane vibrates, which can be felt by touching it. जैसे तुमने उसको hit किया, तुम देखोगे drum का जो membrane है, वो vibrate कर रहा है. You can also feel it by touching it that it is vibrating. As long as the drum is vibrating, the sound is heard. As the membrane stops vibrating, no sound is heard. This shows that the vibrating drum produces sound. Very simple. What is the next experiment? If the string of a guitar or a sitar is plugged, the string starts vibrating and its sound is heard, isn't it? Similarly, on blowing a whistle, the air in the whistle starts vibrating and sound is heard. All right, these are very simple facts, very simple experiments. So basically, we conclude that sound is produced when a body vibrates. As it stops vibrating, what happens? The sound produced by it stops. So see what is written in red. A vibrating body is a source of sound. Simple. Now, sound के बारे में क्या लिखा हुआ है? Mechanical energy is required to start vibrations in a body producing sound. The vibrations of a body are transmitted in medium in form of waves. This is important. Now, these vibrations, which are done by the body, like the string of a guitar. Suppose the string of a guitar is vibrating. These vibrations are transmitted in the medium. Medium मतलब कोई भी हो सकता है. Medium air हो सकता है, water हो सकता है. Let us say we are plucking the string of the guitar in air, है ना? So what happens? Those vibrations of the string of the guitar are transmitted in air in the form of waves. From that point to the next, from that point मतलब वो गिटार के स्ट्रिंग से to the next and so on. तो ऐसे धीरे 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 वो पूरे मीडियम में आगे बढ़ता है. जहां से गिटार का स्ट्रिंग है वहां से स्टार्ट हुआ एंड वो वाइब्रेशंस वेव के तरह पूरे मीडियम में धीरे धीरे प्रोपगेट होता है. दिस इज नोन एज प्रोपगेशन ऑफ द साउंड. नाउ दीज वेव्स ऑन रीचिंग द ईयर्स, ये वेव्स हमारे कानों में आकर हमारे ईयर ड्रम को भी वाइब्रेशन में लाता है. सो प्रोड्यूस वाइब्रेशंस इन द ईयर ड्रम व्हिच आर परसीव्ड एज साउंड बाय अस. All right, so this is how sound actually propagates and reaches to our ears. It vibrates the eardrum and we can perceive that sound. Thus, sound is a form of energy. All right, now how does sound propagate? It requires a medium, we all know. And to prove this, there is an experiment. So here a very easy and a basic experiment has been discussed, but this is an important experiment, but very simple experiment to show that sound requires a medium for propagation. If there is no medium, sound cannot propagate, means sound cannot travel. So what has been done, a bell jar has been taken. This is basically a glass jar which is transparent. You can obviously see the things inside, and there's an electric bell kept inside this bell jar connected with battery and a key. So when we press the key, means when we switch on the key, what happens, current flows through the circuit and the bell jar starts ringing. We can see the hammer striking the gong. We can see that the hammer is striking the gong, and if there is air inside the bell jar, we can even take out the air by using a vacuum pump. So there's a system over here. You can see two vacuum pump, means we can take out all the air inside this bell jar and create a vacuum inside the bell jar, and we can lock this. Means we can simply lock the entire thing with no air inside it. Means we can create a vacuum. वो हम कर सकते हैं using this system, two vacuum pump. But in the first case, what we would do, we would not take out the air. So let the air be inside the bell jar, and then we would press the switch on, press the key on. We would be seeing that the electric bell is ringing. How we would be seeing it? By looking at the hammer which is hitting the gong. हम देखेंगे कि ये hammer gong को hit कर रहा है, and also at the same time we would be able to hear the sound that is produced. तो हमें वो टंग 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 sound सुनाई देगा. The reason why we would be able to hear the sound is ये जो sound है जो इस bell से निकल रहा है, electric bell से निकल रहा है, that is propagated to the glass jar, to the walls of the bell jar. क्योंकि कैसे propagate हुआ? Because there is air. अगर यहाँ पे एयर नहीं होता तो वो ग्लास जार तक पहुंचता ही नहीं, प्रोपगेशन होता ही नहीं. सो एयर के थ्रू दीज वाइब्रेशंस आर ट्रांसमिटेड as waves to this glass jar, and this glass jar comes in the state of vibrations, and this vibrating glass jar then further transmits those vibrations. यहाँ पे हमारा कान है, we are near the bell jar, हमारे कानों तक जाता है, we are able to hear the sound. But now what do? We would take out all the air out of this bell jar using this vacuum system. Now we have created a vacuum. There's no air inside the bell jar. Now when we press the key on, we would be able to see the bell ringing. We would be able to see the hammer striking the gong. हमें दिखेगा कि हाँ वो तो hit कर रहा है, but we would not be able to hear any sound, because although the body is vibrating, that energy is not being able to propagate. वो यहाँ पे वाइब्रेट तो कर रहा है, but those vibrations are not being transmitted because of no medium. तो यहाँ से वो transmit ही नहीं हो पाएगा. As a result, the sound does not come out and we will not be able to hear any sound, although we would be able to see that the bell is ringing. तो वही यहाँ पे लिखा हुआ है. You see the explanation. I would be reading the explanation. This is what I have explained. When the hammer of its bell hits the gong, sound is produced due to the vibrations of the gong, which travels through the air to the walls of the jar. This causes the wall of the jar to vibrate, due to which the air outside the jar also is set into vibrations. This sound is heard by us. ये तब जब air है अंदर में. अब जब air को हमने निकाल दिया. But when the air has been removed from the jar, sound produced due to the vibrations of gong could not travel to the walls of the jar. So wall could not vibrate and no sound is heard. This clearly demonstrates that sound requires a material medium for its transmission and it cannot travel through vacuum. ये जो explanation है जो मैंने यहाँ first bracket किया यहाँ से यहाँ तक, this is when air is present inside the bell jar, and दूसरा जो bracket किया when air is not present inside the bell jar. ये exam में question आ सकता है, ये figure question paper में बना हुआ हो सकता है, and they would also ask you to explain that why the bell is heard, the ring sound is heard in the first case, and why we are unable to hear it in the second case. Second case means when air has been removed. तुम्हें ये पूरा explanation अच्छे से लिखना पड़ेगा. This is what I have explained you just now. All right. So what can we conclude from this experiment? That a material medium is required for the propagation. Propagation means travel of sound from one place to another. This medium could be air, could be water, it could be solids also, but it needs a medium definitely. Now, what are the requisites of a medium? Requisites of a medium means क्या क्या प्रॉपर्टीज होने चाहिए जिसको हम तभी हम उसे मीडियम बोलेंगे. क्या क्या प्रॉपर्टीज होने चाहिए उस मीडियम को मीडियम बनने के लिए. Air is a medium. Why air is a medium? What properties does air possess that we are calling it a medium? Water is also medium. What properties water possesses that we can call it a medium? The first property is that medium must be elastic. What does it mean? Elastic means that the particles must immediately come back to its initial position after displacement on the other side. You see, the air molecules, they vibrate. While this, we have just discussed just now that while this bell is vibrating, the vibrations are transferred to the neighboring air molecule. Then this neighboring air molecule would transmit its vibrations to the next neighboring molecule. And in this way, each of the molecules, neighboring molecules are set into vibrations, and finally it reaches to the ears. And then these vibrations are transmitted to our eardrum. So ये जो air molecule vibrate कर रहा है एक के बाद एक. So what happens? Let this be the air molecule. Vibration means it is going to its extreme position, and again coming to its mean position, going to the another extreme position, and again coming to its mean position. So vibrating means आगे पीछे or to and fro motion. So this must be there. अगर ऐसा होता कि medium particle ने mean position से extreme position गया, फिर वापस वो आ नहीं रहा, it is not coming back to its mean position, then that is not oscillation, right? So air molecules, air is said to be elastic in nature because its particles come back to their initial positions after displacement on either side. Simple. So ये वाइब्रेशन होने के लिए हमें ये पार्टिकल को टू एंड फ्रो मोशन करना पड़ेगा. Means the particle medium must be elastic in nature. This is the first point. The medium must have inertia. Inertia is possessed only by those bodies which have some mass. If something doesn't have mass, it cannot possess inertia. So air molecules possess mass. We know, we have studied in class 5 that air has weight. पढ़े हो ना, एक एक्सपेरिमेंट किया था बैलून का कि एक दो बैलून ले लिया, दोनों को एकदम परफेक्टली हॉरिजॉन्टल तुमने बैलेंस कर लिया, टू इन्फ्लेटेड बैलून. नाउ यू prick one of the balloons, उसको डिफ्लेट कर दो, द हेवियर बैलून वुड जो प्रिक नहीं है, जो इन्फ्लेटेड बैलून के साइड में वो झुक जाएगा. सो दिस एक्सपेरिमेंट प्रूव्स दैट एयर हैज वेट. एयर हैज वेट मींस एयर हैज मास, जिसका मास होगा उसी का वेट होगा. सो दैट मींस व्हाट? द मीडियम एयर मॉलिक्यूल्स हैव सम मास, सो इट हैज इनर्शिया. इनर्शिया होने की वजह से इट कैन स्टोर द मैकेनिकल एनर्जी. ये एनर्जी को यहाँ स्टोर करेगा, तभी उसे आगे ट्रांसमिट करेगा. So each and every molecule is first storing the energy and then transmitting it to the next molecule. फिर next molecule तो store करने के बाद ही हम उसे transmit कर सकते हैं. Without storing the energy, how can energy be transmitted further? So to store the energy, the medium particles must have some inertia. This is the second important requisite of a medium. Third क्या है? The medium should be frictionless. Although this is not 100% possible, but yes, the friction should be very less. So the medium should be frictionless so that there is no loss of energy in propagation of sound through it. हालांकि ये 100% हमें frictionless मिलता नहीं है, लेकिन कम friction हम कर सकते हैं. So you see air molecules and another air molecules, when this molecule is, the first molecule is vibrating, it's actually, colliding with the next molecule to transmit its own energy. Suppose इसके पास x joules of energy है फर्स्ट वाले मॉलिक्यूल को, और इसने वाइब्रेट करते हुए दूसरे मॉलिक्यूल को हिट किया, अपने नेबरिंग मॉलिक्यूल को हिट किया, एंड उसमें उसने फिर अपना ये x जूल्स को ट्रांसमिट कर दिया. अब ये x जूल्स फर्स्ट मॉलिक्यूल से सेकंड मॉलिक्यूल में एनर्जी ट्रांसमिट हो गया, फिर वो सेकंड से थर्ड में जाएगा. सो ये जो कोलिजन हो रहा है, धक्का मारकर अपना एनर्जी दूसरे को दे देना, सो इसमें एनर्जी लॉस नहीं होना चाहिए. प्रैक्टिकली ऐसा होता नहीं है. x joules is not actually transmitted as x joules. If the first molecule has x joules of energy, the second molecule will have something less than x joules of energy. फिर third molecule will have even less than the second molecule also. धीरे धीरे जो एनर्जी ट्रांसमिट हो रहा है वो थोड़ा कम कम होते जा रहा है, बिकॉज पूरा 100% ट्रांसमिशन होता नहीं है, बिकॉज सम एनर्जी इज लॉस्ट बिकॉज ऑफ फ्रिक्शन. एक मॉलिक्यूल दूसरे मॉलिक्यूल के साथ जब कॉन्टैक्ट में आ रहा है तो फ्रिक्शन हो ही रहा है. एंड ये फ्रिक्शन बहुत ही नेग्लिजिबल है, लेकिन एकदम जीरो फ्रिक्शन नहीं होता है। फ्रिक्शनलेस कहीं पे भी हमारे यूनिवर्स में नहीं है। तो frictionless surfaces. So when two surfaces are coming in contact, there has to be a friction, and therefore there is some loss of energy. But if this loss would be too much, means if there would be a too much of friction, then the energy cannot be transmitted to the next one. हाँ, थोड़ा सा यहाँ फ्रिक्शन, इसलिए थोड़ा लॉस होता है धीरे धीरे, तो ट्रांसमिशन हो सकता है। बट एक आइडियल मीडियम की हम बात कर रहे हैं, आइडियल मीडियम की, विच इज where we would say that it should be frictionless. अगर पूरी तरह से frictionless होता, तो x joules of the first molecule would be transmitted to the second molecule as x joules only and not less than x joules. वो ideal situation है, जो imaginary है लेकिन ideal है। Ideal medium में क्या होना चाहिए? The medium should be frictionless so that there is no loss of energy in propagation of sound through it. I hope these 3 points are clear, and these points are, this is a very important question you would be getting in your exam. Okay, 3 important conditions or 3 important properties of a medium. अब लिखा हुआ है sound can propagate not only in gases but also in solids and liquids, because these properties 1, 2, 3 are present in solids as well as in liquids. Some materials such as air, water, iron, etc. can transmit sound through them from one place to another. On the other hand, blanket, thick curtains, etc. absorb most of the sound incident on them and transmit or reflect only a small fraction of it. तो जो हमारे rigid bodies होते हैं, जैसे iron, solid की बात कर रहे हैं, rigid solids, वो उसमें क्या होता है, sound propagate करता है. In fact, there are some experiments which prove that sound travels through iron very easily. वो rail वाला experiment. If a train is coming from a very far distance, you are unable to hear the sound of the train through air. But if you place your ears on the railway track, you would be able to hear the vibrations of the train, which is at a very far distance, but still the sound is coming to you through the rails, but not coming through the air. हालांकि ये करना थोड़ा डेंजरस हो सकता है, बिकॉज रेल्स में अपना कान को रखना could be dangerous. Don't do this, but this can be experienced if you do it. All right, so this proves that sound can travel through iron. Iron is a solid, rigid solid. But if you have a blanket, curtain, these are not rigid, these are soft solids. And these soft solids, they have a property of absorbing the sound. So they absorb the sound and they do not transmit this, a good amount of sound, because major part of sound is absorbed by them. यही यहाँ पे लिखा हुआ है. Sound cannot travel in vacuum. इसी experiment से ये prove भी हो गया. Vacuum था तो sound हमें सुनाई नहीं दिया. So sound cannot propagate, cannot travel in vacuum. On moon, there is no medium because there is no air, all right? So on moon, one cannot hear the sound produced by the others. Very simple thing. Light एक ऐसा एनर्जी है जिसको मीडियम नहीं चाहिए. सी साउंड इज ऑल्सो फॉर्म ऑफ एनर्जी. अभी अभी हमने पढ़ा साउंड इज अ फॉर्म ऑफ एनर्जी, लाइट इज ऑल्सो फॉर्म ऑफ एनर्जी. बट दोनों में डिफरेंस क्या है कि लाइट डज नॉट रिक्वायर एनी मीडियम फॉर प्रोपगेशन, बट sound requires a medium for propagation. Light can travel in vacuum as well, but light can travel in vacuum as well, but sound cannot travel in vacuum, right? This topic now, which we are going to start, is a very important topic, which is propagation of sound in a medium. How does sound propagate in a medium? All right. And here it has been explained with respect to air, majorly air. This basic, the diagram which has been shown and the explanation which has been done to you is propagation of sound in air as a medium. So यहाँ देखो air layers की बात किया गया है. ये बहुत ही important topic है. ये diagram तुम्हें समझना है और किस तरह से sound propagate करता है air में, travel करता है air में, वो एक visualization से तुम्हें यहाँ पे समझाया गया है. And this can come in your exam. इसमें क्या लिखना है, क्या important है, अब मैं इस पे explanation करता हूँ. Now before I proceed with the explanation, एक थोड़ा सा important and थोड़ा सा time लगेगा और बहुत important चीज हम discuss करने वाले हैं regarding your upcoming session class 10th. अभी तुम लोग 9th में हो, लेकिन अभी से कुछ महीनों बाद you would be moving to class 10th, right? Class 10th is a very important academic session for you because you would be appearing for board examinations. ICSE board examinations 2023-24, isn't it? So this is your academic session for class 10th. Now here you need proper guidance because class 10th is not a very easy thing. So there are a lot of concepts, a lot of things. So if you want a proper guidance and you want to join my regular batch means it's a live live course, live online classes are going on, will be going on in this course. And if you want to join the regular batch of class 10th in your upcoming session, then the link of all the details for this course is provided in a video. The link of that video is given in the description box of this video. तो आज इसी वीडियो के डिस्क्रिप्शन में चेक करना, तुम्हें वो लिंक मिल जाएगा जिसमें इस कोर्स के बारे में, इस कोर्स का क्या फीस है, क्या रूटीन है, पूरा कोर्स का डिजाइन एंड एवरीथिंग इज एक्सप्लेन्ड। किस प्लेटफॉर्म में हम पढ़ाएंगे, देयर इज अ वाइज ऐप जिसमें हमारा लाइव क्लासेस होगा। And this is going to be a paid course, not a free course, not a recorded course. It is going to be a live, real-time course hoga, and we would be covering physics, chemistry, and computer applications. The duration of the course is 1 year. This is a 1 year long intensive course. मतलब पूरे साल भर 10th का तुम्हारा ये classes चलेगा, just like any regular course. तुम्हें बहुत ही personalized experience होगा, and you would be realizing that yes, Sunandar sir is directly mentoring me, directly guiding me. You would be under my direct mentorship. बहुत सारी चीजें हैं इस कोर्स में, and you would be preparing yourself in an excellent, super excellent manner for your class 10th board examinations coming in the upcoming session. To know all the details, visit the link given in the description box. Also discuss the same with your parents. अभी हम आगे बढ़ते हैं। इस कोर्स के लिए एनरोलमेंट स्टार्ट हो गया है, सीट्स लिमिटेड है। अगर बुकिंग कंप्लीट हो जाएगा फिर हमारा admissions बंद हो जाएगा। All right, so you need to book your seat well in advance. Coming to this topic now, propagation of sound in a medium. Okay, when a source of sound vibrates, it creates a periodic disturbance in the medium. Near it, the state of particles of the medium changes, जो कि हमने अभी बताया था. In the figure, they have taken a metallic strip. This metallic strip is not set into vibrations. देखो वो रेस्ट में है, ये रेड कलर का metallic strip अभी वाइब्रेट नहीं कर रहा है। तो नहीं कर रहा है तो एयर लेयर्स जो उसके सामने हैं, एयर मॉलिक्यूल्स, बेसिकली एयर मॉलिक्यूल्स जो होते हैं, दे हैव बीन शोन ओवर हियर एज एयर लेयर्स। तो जो एयर लेयर्स है वो इक्विडिस्टेंट है, ईच ऑफ द एयर लेयर्स आर एट equal distance from each other. That means there is no disturbance created. Now what happens, the moment this metallic strip is set into vibrations, जैसे अभी ये mean position से extreme position पर गया, देखो यहाँ पे ये extreme position है, ये mean position था, mean से अभी extreme position में गया, what happens, you can see the air layers, the adjacent air layer, you know, they are also pushed, and a region of compression comes. Compression means you can see these red lines come closer, and while ये जो दूर वाले जो air layers है, they are still farther from each other. Alright, so यहाँ पर एक high pressure region, या फिर हम बोल सकते हैं high density region, एक high density region is created क्योंकि यहाँ पे air layers come closer. This region of higher density is known as compression. इस region को हम क्या बोलते हैं, compression. कंप्रेशन को सी से डिनोट किया जाता है। तो देखो यहाँ पर इस जहां पे एयर लेयर्स क्लोज आ गया है उसके ऊपर सी लिखा हुआ है, सी इज डिनोटिंग कंप्रेशन। नाउ व्हाट हैपेंस, अगेन फ्रॉम द एक्सट्रीम पोजीशन दिस मेटालिक स्ट्रिप कम्स बैक टू इट्स मीन पोजीशन। तो वो बी, ए से बी गया था, अब फिर बी से ए पोजीशन पर आ गया, मतलब अपने मीन पोजीशन पर आ गया। तो अभी क्या हुआ, द एडजेसेंट एयर लेयर नाउ takes its normal form, the air layers are equidistant, while that layer, those air layers which came closer where compression was there developed, that got transmitted further. वो आगे transmit हो गया, ये अपने आगे transmit हो गया. Okay, that means this compression region जहां पे डेंसिटी कम हो गया था, वो अपना एनर्जी आगे वाले एयर लेयर को ट्रांसमिट किया, और वो आगे वाला फिर कंप्रेशन के स्टेट में आ गया. While these air layers, they regain their original form. तो ये compression region देखो धीरे धीरे आगे बढ़ रहा है. Now what happens in the next case when it goes to the another extreme position, फिर A से C गया, this metallic strip goes to its another extreme position. So वो फिर पीछे गया, the air layers got separated, the distance increased between them. So a new thing happens over here. यहाँ पर normal distance था, यहाँ पर close distance था. अब जब ये और पीछे लेकर गए तो a new thing happens, the air layers distended apart, they got even far apart. अब देखो air layers पहले normal के तुलना में काफी दूर दूर हो गए. That means here we have obtained a low density region. जहां कंप्रेशन हुआ था वहां था हाई डेंसिटी रीजन, जहां पे ये लो डेंसिटी रीजन क्रिएट हुआ, दैट इज नोन एज रेयरफैक्शन, and that is denoted by R. So what is compression? Compression is the region of higher density in the air, where the air layers come closer to each other. And what is rarefaction? Rarefaction is basically that region in the air where the air layers are far separated, and that is a region of low pressure. You can also say low density or low pressure, दोनों बोल सकते हो. High density यहाँ बोल सकते हो, high pressure भी बोल सकते हो, low density बोल सकते हो, low pressure region भी बोल सकते हो. So it's basically low pressure region is rarefaction. This rarefaction is also transmitted further. Now you see यहाँ पे ये rarefaction region आगे transmit हो गया, compression region भी आगे transmit हो रहा है. So a chain of rarefactions and compressions is produced, and this keeps on propagating. धीरे धीरे you can see the compression region is propagating further, and इसी तरह से धीरे धीरे this rarefaction region will also keep on propagating further. This rarefaction and compression, this is how the sound propagates in air. अब क्या लिखा हुआ है हम उसको पढ़ते हैं. देखो, तुम्हें एग्जाम में आएगा तो तुम्हें क्या लिखना पड़ेगा. एग्जाम्पल 1 को पढ़ते हैं. जो मैंने अभी एक्सप्लेन किया वही लिखा हुआ है. टेक अ थिन मेटल स्ट्रिप, कीप इट वर्टिकल, फिक्स इट्स लोअर एंड. Okay, we have fixed its lower end. Now push its upper end to one side and then release it. Means we are setting it into vibrations. As it vibrates, it moves alternatively to the right and left, and sound is heard. All right. Now this figure shows the undisturbed, the first one, A. We are talking about A, the normal condition when it is not vibrating. So this A shows the undisturbed or normal position of the metallic strip, and the air layers on the right side of the near the metallic strip is their undisturbed or normal position, where the air layers are at equidistant. As the strip moves to the right from A to B, it pushes the particles of the air in layers in front of it. So the particles of air in these layers get closer to each other. यहाँ पे close आ गया, push किया तो, and ये जो गया compression is formed. The particles of these layers, while moving towards right, push and compress the airs next to them. फिर ये अपने next वाले को push किया, and so on. And what happens? This is how the compression region propagates further. The particles of these layers, while moving towards right, push and compress the layers next to them, which then compress the next layers, and so on. Thus, the disturbance moves forward in form of compression. The particles of medium get displaced, but they do not move along with the compressions. देखो, यहां पर क्या बोला जा रहा है, ये जो एयर पार्टिकल्स है वो आगे खुद नहीं आगे बढ़ा, ये अपने जगह पर ही वाइब्रेट कर रहा है. उसने अपनी एनर्जी को एडजेसेंट वाले एयर लेयर्स को ट्रांसमिट किया. सो द एडजेसेंट वाले एयर लेयर्स दे कम इन द स्टेट ऑफ कंप्रेशन. फिर यहां पर ये कंप्रेशन के स्टेट में आ गया. फिर ये अपने जगह पर ही है, लेकिन ये अपने एडजेसेंट वाले को फिर कंप्रेशन कर दिया. दैट मींस दिस वन इज बेसिकली, पहले जो नॉर्मल था वो अब कंप्रेशन के स्टेट में आ गया. In this way, the air particles are not moving, from one place to the another place. They are at their own place and vibrating. What is happening? They are just transferring their disturbance, transferring their vibrations to the next one, next one, next one, neighboring air layers. वही लिखा हुआ है, the particles of the medium get displaced, but they do not move along with compression. Displaced मतलब वो अपने ही प्लेस पर वाइब्रेट कर रहा है. पार्टिकल्स अपने पोजीशन से डिस्प्लेस तो कर रहा है क्योंकि उसे वाइब्रेट करना है, लेकिन it is vibrating at its own place. They are not moving along with the compression. All right. Now अब ये return path rarefaction को explain किया गया है. As the metal strips starts returning from B to A after pushing the particles in front, the particles of air near the strip starts returning back to their mean positions. And what happens due to the elasticity of the medium, वो अपने mean position पर वापस आना चाह रहा है, जिसके वजह से क्या हो रहा है, as when the strips moves to the left from A to C, it pushes back the layers of the air near it towards the left side में push back किया air layers, thus produces a space of very low pressure on its right. All right, the low pressure region created on the right side. As a result, what happens? The air layers on the right side of the strip expands in this region, thus forming the rarefied air layers. Now what happens basically over here, जैसे ही वो पीछे के तरफ गया, अपने जो उसके जो लेफ्ट साइड वाले एयर लेयर्स थे उनमें कंप्रेशन आ गया जब वो पीछे की तरफ गया. However, यहाँ पर क्या हुआ, the air layers got rarefied. Rarefied means they got far separated from each other. And this is what rarefaction happens. So this region of low pressure is known as rarefaction. And the rarefaction is also transmitted further. You can see from here, it now got transmitted to this place. So rarefaction is also transmitted as compression region only. So this is how it proceeds further. All right, so this is basically a little big topic, but you have to write in your exam this particular paragraph. What happens when it is in the undisturbed state? What happens when it is in the disturbed state? And what happens when it is going to the another extreme position? Means this you can the C also and this D. So all the four things you need to explain. And then this E again. What happens in E? When the strip returns from C to its normal position, it pushes the rarefaction R forward. Rarefaction is pushed forward, and the air layers near the strip again pass through their mean positions due to the elasticity of the medium. So due to the elasticity of the medium, what happens? The air layers again go to their mean position. तो ये जो अपने जहां rarefaction हुआ था वो फिर से अपने ओरिजिनल स्टेट में आ गया because of the elasticity of the medium. However, the rarefaction region is transmitted further, तो उसके आगे वाले जो air layers है वो rarefied हो जाएंगे. कुछ देर बाद फिर वो normal हो जाएगा और उसके आगे वाला फिर rarefied हो जाएगा. In this way, the rarefaction region is transmitted further. And this is how the sound propagates. So you need to write all these 5 paragraphs. A का हमने bracket कर दिया, B का, C का, D का and E का. So this is what you are going to write. फिर last में लिखना क्या? This wave in which the particles of medium vibrate about their mean position in the direction of propagation of sound is called a longitudinal wave. Thus, sound travels in air in the form of longitudinal waves. ये लास्ट में लिखना बहुत जरूरी है. सो अगर तुम्हारे एक क्वेश्चन में आया हाउ एक्सप्लेन हाउ डज साउंड प्रोपगेट इन मीडियम और हाउ डज साउंड प्रोपगेट इन एयर, तुम्हें ये ए बी ये जो पैराग्राफ्स है ए बी सी डी ई लिखना पड़ेगा, ये फिगर भी बनाना पड़ेगा. एंड दिस लाइन यू हैव टू राइट, दिस वेव इन विच द पार्टिकल्स वाइब्रेट अबाउट देयर मीन पोजीशंस इन द डायरेक्शन ऑफ प्रोपगेशन ऑफ साउंड इज कॉल्ड लॉन्गिट्यूडिनल वेव. Now, what is the meaning of this? I will explain to you. Sound propagate किस डायरेक्शन में कर रहा है चिल्ड्रन? इस डायरेक्शन में कर रहा है. You all will agree? यहां से सपोज ये मेटल स्ट्रिप है, मेटल स्ट्रिप से वो दूसरे साइड में जा रहा है. तो साउंड इज प्रोपगेटिंग इन अ हॉरिजॉन्टल डायरेक्शन along the arrow which I have drawn. ठीक है? तो साउंड प्रोपगेट कर रहा है ऐसे हॉरिजॉन्टल, और उसी डायरेक्शन में मीडियम पार्टिकल्स भी वाइब्रेट कर रहे हैं. एयर लेयर्स आर आल्सो वाइब्रेटिंग आगे एंड पीछे. Means like this. So if I have to ask you what is the angle between the direction of propagation and direction of vibration. So देखो, direction of propagation is also horizontal and direction of vibration, air layers are also vibrating आगे पीछे. So there are also the angle between them is 180 degrees or 0 degrees. अगर जब एयर लेयर्स आगे की तरफ वाइब्रेट किया और डायरेक्शन ऑफ प्रोपगेशन भी आगे की तरफ है, सो द एंगल इज 0 degrees. And in case when we are talking about vibration on the another extreme position, तो उस केस में angle between them is 180 degrees. So either 0 or 180 degrees is the angle between the direction of propagation and direction of vibration. जब इस तरह का सिचुएशन हो where the particles of medium, जो यहाँ लिखा हुआ है, particles of medium are vibrating about their mean position in the direction of propagation. मतलब एंगल 180 या 0 डिग्रीज है, उसे हम बोलते हैं इन द डायरेक्शन ऑफ प्रोपगेशन. उस तरह के वेव को बोला जाता है लॉन्गिट्यूडिनल वेव. एक दूसरा तरह का वेव क्या हो सकता है चिल्ड्रन? इफ द वाइब्रेशंस आर नॉट आगे पीछे, अनलाइक दिस, बट इफ द वाइब्रेशंस आर ऊपर नीचे, कोई पार्टिकल्स ऊपर और नीचे वाइब्रेट कर रहा है, ऊपर नीचे, दिस इज आल्सो टू एंड फ्रो मोशन, लेकिन ऊपर नीचे वाइब्रेट कर रहा है, एंड द डायरेक्शन ऑफ प्रोपगेशन इज लाइक दिस. So the angle between direction of propagation and the angle between vibration is 90 degree. अगर ऐसा हुआ तो हम उस तरह के वेव को बोलते हैं ट्रांसवर्स वेव. बट साउंड में ऐसा नहीं होता है. साउंड में 90 डिग्री नहीं होता है. द एंगल बिटवीन डायरेक्शन ऑफ प्रोपगेशन एंड द डायरेक्शन ऑफ वाइब्रेशन ऑफ द पार्टिकल्स इज नॉट 90 डिग्री, इट इज 180 degrees or 0 degrees. And that we say that the particles are vibrating in the direction of propagation. इस केस में हम in the direction of propagation नहीं बोलेंगे, इसमें बोलेंगे the particles of medium are propagating normally along the direction of propagation, normally to the or perpendicular to the direction of propagation. अगर perpendicular हुआ या normal मतलब ही perpendicular normally हुआ तब उस wave को बोलते हैं transverse wave. Sound is not a transverse wave in air. All right, sound is a longitudinal wave in air. The sound travels in air as longitudinal wave and not transverse wave because the direction of propagation and the particles, the vibration of the particles are in the same direction, along the same direction. All right. So this is what we have done in this topic. We will continue with this chapter further, and till then, God bless you everyone. Take care.